So we're going to look today at problem number 1 from homework last night, from today, on projectile launch above the horizon. So we have a projectile that's going to be kicked off the top of the tower, 12 meters tall, 35 degrees above the horizon at 35 meters per second. First thing we need is find the x and y components of that, so we know how fast it's going into x, how fast it's going into y. In the y component would be sine 35 times 35, or 20 meters per second. Y would be my initial velocity y. My x component would be cosine 35 times 35, or 28.7 meters per second x. It's going to go that x velocity all the time until it hits something. So the next thing I have to figure out is how long is it going to be in the air. Because to find out how far it's actually going to travel before it lands, I need velocity times time, which should be equal to displacement or distance. So I have to break the motion down into two segments. First is going to be how it's going to go up and stop briefly in terms of vertical motion. Then it's going to fall from that highest point all the way back down to the ground. The total time will be in the air will be the time it takes to get up there and stop, and then the time it takes to fall back down. So in order for it to get up there and stop, my final velocity would be y, would be up, would be 0. So I start at 20. I can use Vf equals V naught plus At and say that 0 equals 20 minus 9.8 of t, and the time it takes to get to the top will then be 2.05 seconds, 2.04 seconds. How far does it travel during that time? I want to look at two different things I could do, but I could say the height equals where I started, 12.0, plus my initial velocity of 20 times 2.04, minus 1/2 of 9.8 times 2.04 squared. And that gives me 12 plus 40.8 minus 20.4 for a total height of 32.4 meters. Now a couple things. That final position in terms of going up will become my initial position when I start to fall back down, 32.4 meters. My final velocity up, which is 0, becomes my initial velocity for the downward component. So now I know that when I hit the ground, my final position will be 0. My final velocity coming down will be something that I think I need to find during that time so I can find the overall net velocity at the end, but we'll talk about that in a second. So now I try to find out how long it's going to take to get to the bottom. I can look at the same thing. In this case, h should be equal to 1/2 of at squared. So that the time down should be equal to the square root of 2h over a. And that time to take to fall down should be 2.57 seconds. So my total time that I'm going to be in the air, 2.57 plus 2.04, or 4.61 seconds. The last thing I don't really know over here then in terms of coming down is how fast is it going in the x direction when it lands. I can get that from Vf squared equals V naught squared plus 2ax, or 2ay in this case, and that final velocity negative 25.2 meters per second. So when it hits the ground, it's going to be going 25.2. So if I look at how far out there is it going to go, I take my velocity, 28.7, my total time, 4.61, and that gives me a total distance of 132 meters. And then when it lands, I've got to look at the balls going 28.7x and 25.2y. I need to find that resultant velocity. So it'd be Pythagorean theorem, 28.7 squared plus 25.2 squared square root should give me that magnitude, or how fast is it actually going during that time. Should be like 38.2 meters per second. And of course we could look at finding that direction there if we wanted to. But that's just a look at how we're going to work those problems. We're going to break them down. the formulas we might see. You're going to use those motion formulas, kinematics formulas, to look at the motion going up and coming back down, realizing that that time for the upward, the time for the downward is going to go to give me my total time in the air. Remember, the whole time I'm going up, I'm walking into X, coming down, I'm going into X. So we want to make sure we have that good example. That's the same sort of approach you're going to use to the rest of those problems for tonight. So good luck with that, and we'll see you tomorrow.